Hello, welcome back. In this video, we'll continue with orthographic projections. We are going to solve a problem which was asked in last Mumbai University question paper, December 18. Read the problem. Pictorial view of a machine part is shown in the figure. Draw front view, top view, and insert at least 6 dimensions. Okay, watch the diagram. It is not a symmetrical object. Also, it's not a object in which we can identify parts which are assembled or connected together. It's one single block bounded by different surfaces. The first approach we studied in second video on orthographic projections, that is, we'll check the surfaces, principal surfaces and principal edges first to continue with front view, top view and side view. Okay, now let's proceed. Okay, but before that, I'll suggest you to watch my first and second video on orthographic projections. Without that, don't watch this video. You will face a lot of difficulties in understanding the video. Okay, let's proceed. As usual, we'll have to decide orientation of length and width. Height axis is vertical, and now you know axis parallel to this arrow. This arrow suggests front side of the object. Parallel to this arrow, that is width axis. So width and length orientation we have identified. Now check all dimensions. Parallel to length from left side to right side, it is 84 millimeters. So length is 84 millimeters. Now parallel to width, check all dimensions from front to back. So 55 plus 25. 55 plus 25. That is 80. So width of the object is 80 millimeters. Now check height of the object. Focus on all vertical dimensions. Check here. From bottom to top, dimension is already given 72 millimeters. So we didn't face any difficulty in identifying overall dimensions. Now with these dimensions, width 80 millimeters, length 84 millimeters and height 72 millimeters, will construct a rectangular blocks here. Which two dimensions you get in the front view? Correct. Length horizontally and height vertically. So length 84 will measure horizontally, height 72 millimeters will measure vertically and will complete a rectangular box for front view. And this is how we have completed rectangular box for front view. Now length 84 we should project downwards in the top view. Tell me which two dimensions you get in the top view? Length horizontally and width vertically. Correct. So length we need not measure again. Instead we should project that length 84 millimeters. So draw end projectors so that length 84 millimeters is there in the top view, and width vertically you should measure. How much is width of the object? 80 millimeters. So we should measure 80 millimeters vertically to complete a rectangular box. So this is how we have completed box for front view, length horizontal, height vertical, and for top view, length horizontal 84, height vertical 80. Now listen. In university exam problem, it is asked to draw only two views, front view and top view. But we are not in exam hall, we are practicing. So now we'll draw side view also. In isometric view, right side view is visible. Okay, so let's draw right side view. Now right side view to be drawn on the left side of front view. So in this position, we are going to draw side view. So we'll construct a rectangular block for side view. Tell me, which two dimensions you get in the side view? Correct. Height vertically and width horizontally. So width already we have measured in the top view. Now this width we should measure horizontally here. So let's do that. Draw a 45 degrees line to draw width, projector for width from top view to side view. So this is how I have transferred height in the side view and draw projectors to transfer width in the side view, and this is how we have completed the rectangular box for side view. So this is how we have completed 3 boxes for front view, top view and side view. Now we'll proceed. So here we'll focus on principal surfaces and principal edges. What exactly principal edge is and what are principal surfaces? To know that, watch video number 2 on orthographic projections. Let's proceed. Now watch this surface. This surface has 2 principal edges which are perpendicular to each other. This edge, remember again, edges which are perpendicular to the reference axis are principal edges. If a surface has 2 principal edges perpendicular to each other, then that is principal surface, which shows a true shape in corresponding view. For example, this small rectangular strip-like surface here has one edge here parallel to height axis and an edge parallel to length axis. So 2 perpendicular principal edges, height and length. Tell me in which view we can see height and length? In front view, correct. So in front view this surface shows its true shape. So we'll draw this true shape in the front view. From left corner, measure height vertically, in the front view height vertically, and length 28 mm horizontally, so that we'll able to complete a rectangular surface here, that is this rectangular surface. Let's do that. So 28 by 8. So these are all principal edges parallel to height and parallel to length, and this surface is complete in the front view. Now focus on this surface. This is also a principal surface. It has 2 edges perpendicular to each other, principal edges. This edge parallel to height axis and this edge parallel to length axis. So that suggested you that this surface appears in its true shape in front view, the view in which height and length visible. Height and length view, that is a front view. So here we are going to draw shape of that surface. Now how to construct the shape? Remember I told you, first curved edges, then principal edges, and then non-principal edges. So let's draw this curved edge. It is quarter circular edge of radius 32. So from right end, measure 32 horizontally, parallel to length axis, and 32 vertically, parallel to height axis, to locate center of this quarter circular edge. Watch here. 32, this is center line to locate the center, and 32 parallel to height, and draw the center line. So this is how we have located the center. Now with this center, radius 32, complete quarter circular arc. Now this surface has one more curved edge. It is semicircular edge. So let's draw this edge. Now to draw this semicircular edge, we'll have to locate its center, which is 32 plus 12 millimeters from a right end. So from right end 32 we have already measured. Now measure 12 millimeters to locate the center. So now here is the center of that semicircular edge. Radius of this semicircular edge is 12 millimeters. So use this center and draw semicircular edge of radius 12 millimeters. Correct. Now let's proceed with principal edges. Now watch here. This edge here, from end of semicircular edge, this vertical edge is principal edge. Then this principal edge. These are all principal edges which are parallel to height and length axis. So let's draw this edge. Start from end of semicircular edge upwards and it ends 8 plus 16, that is 24 millimeters from top it ends. So here 8 plus 16, here that edge must end. So we have drawn this vertical edge. Then this principal edge which is here, this horizontal principal edge here, this edge. Then principal edge at base and this principal edge parallel to it. So this is how we have completed this shape. Okay, now watch this surface. It shows its true shape in front view because it has two principal edges, parallel to height, parallel to length. So when a surface has two principal edges which are perpendicular to each other, then that is principal surface. It shows its true shape in one of the views. This surface has edge parallel to height, parallel to length. Which view gives height and length? Front view. So this surface gives its true shape in the front view. Now just check. Do you know where is this surface, this rectangular surface in the front view? So try to understand. This surface has two principal edges perpendicular to each other, but one is parallel to width and the other is parallel to length. Which view gives you length and width? Top view. So this surface shows its true shape in the top view. In front view, this entire surface appears a line because this surface has a principal edge which is parallel to width, and width doesn't appear in the front view, and therefore this surface doesn't appear in the front view. In front view it appears a line. So this surface is nothing but this line. Okay, so above this surface means above this line, draw vertical edge 32 millimeters. So measure 32 millimeters vertically. Watch here. So now parallel to length edge, this edge is parallel to length at distance 32 millimeters. So this is that edge. I have not made it dark yet because it is connected to a curved edge here. So we'll draw as usual to complete the shape here. We'll draw this curved edge first. So from this corner here, measure from this corner because we want to draw quarter circular curve here. Correct? We want to draw quarter circular curve here. So from corresponding corner, measure 15 millimeters horizontally, draw a center line, and 15 millimeters vertically, draw a center line, and this is how we have completed quarter circular arc of radius 15 millimeters from this center. And now draw all other principal edges. Watch this vertical 32 millimeter long edge, this horizontal edge, it is here, and this vertical edge. So we have completed this shape. Is front view over? No, not yet. Check here, there is one more surface. It is partially hidden. This rectangular surface has height 16 millimeter. Watch here, it's given 16 millimeter here, and length 28 millimeters. This length is 28 millimeters. Watch here, these edges are 28 millimeters long. So this surface is partially hidden, but from front it is completely visible. It has principal edges 28 millimeters, which we have already drawn. Then 16 millimeters vertical, one on this side and one on the other side. So those two edges, this is how we have completed that surface. Now tell me, is this diagram over? Not yet. Remember, right now we have thought about Visible surfaces. When you draw a visible surface, automatically corresponding edges will appear here. So surface is visible. That means all its edges are visible. So these visible surfaces and therefore visible edges we have completed. Now this is front view. Check on the back side. Are there corners on the back side? Yes. Check this corner. From front, the three edges at this corner are not visible. This edge, it is in this surface. That surface, this surface, watch here, this surface. This entire surface appears a line in the front view. Remember, if a surface has an edge parallel to width axis, tell me, in which view width doesn't appear? Front view. It means in front view this surface does not appear. In the sense it appears a line. So this surface appears a line here. So all edges on this surface appear on the same line. So this edge is already there. This vertical edge also already there. Now what I am telling you, that is a corner is formed by three edges. So where is that third edge from this corner? So listen, check all other corners of this surface. This corner, there is an edge parallel to length axis. From this corner, there is an edge parallel to length axis. Any corner of this surface you check. From this corner, there is an edge parallel to length axis. All these edges are 28 millimeters long, parallel to length. Similarly, from this corner also, parallel to length, there is edge 28 millimeters long. So this edge, which is on the back side, it is hidden. We are going to draw this edge. It is 25 millimeters from top. So measure 25 millimeters from top and draw that hidden edge. Check. Now, one more thing. From this corner, there is vertical edge. Check here. A corner is formed by three edges. So from this corner also there is vertical edge. That is hidden. Now from this corner there is vertical edge up to the surface. This surface. Such a surface is not on the back side. So vertical edge from here is to be assumed up to the base of the object. So from this corner, there is vertical edge which is visible, we have drawn here. But exactly behind this corner, when you are watching from front, exactly behind this corner there is a corner, and from this corner there is vertical edge. So that vertical edge is from top to bottom. So we are drawing that edge which is hidden. And this is that vertical edge. Check here, I erased that center line first. I removed that center line first. Because when edge coincides with axis, then axis is not important. Axis or center line are not edges of object. These are simply imaginary line. And edges define shape of object. So edges are important. So this hidden edge is actually from top to bottom. In this portion, that hidden edge is coinciding with visible edge. When hidden edge coincides with visible edge, then visible edge is important. So here, this is visible edge. So this is how we have completed the front view. Now let's proceed for top view. Let's proceed for top view. Now again in the top view, we'll think about visible surfaces. This surface, extreme top surface, shows its true shape in the top view. We'll draw this surface first. 28 millimeter parallel to width, 28 millimeter parallel to length. This surface has two principal edges. One is parallel to length, parallel to width. Which view gives length and width? Top view. So this surface appears in its true shape in the top view. So draw these four principal edges to complete that shape here. From left side front corner, measure 28 millimeters parallel to length, and 28 millimeters parallel to width. Yes, and parallel to width. And this is how we have completed the surface. Correct. Now we'll draw this surface. Again, this length is 32 millimeters. Check the radius of this curved edge, and here it is center. So this length is 32, and this length of the surface is 55. Now parallel to width 55 millimeters and parallel to length 32 millimeters from right side. So from right side front corner, measure 55 millimeters parallel to width 55 millimeters and 32 millimeters parallel to length, and complete this rectangle. So this is how 55 millimeter long edges and 32 millimeters long edges, and we have completed this portion. Okay. Now this surface has edges parallel to width and parallel to length. So this surface also shows its true shape in the top view. So let's draw this surface. So from back end 25, from back side 25 millimeters. Okay. So this is that, this edge 25 millimeters. Here it is. Then this edge. And this is how we have completed this surface in the top view. Now there is possibility of confusion. Can you tell me where is this edge? Here in isometric view. So try to understand. You can think in this manner. Do you know, when you draw views of a cylinder, if it is a vertical cylinder, then it appears circle in the top view, but in the front view it appears a rectangle. The boundary edges, boundary of curved surface, also called boundary generators, we make dark. Those are not edges, but those are boundary generators. Remember, there is a curved surface here, and this line is boundary of that curved surface. So it can be considered as boundary of curved surface or boundary generator of this quarter circular surface, quarter cylindrical surface, we can say. Okay, so we have completed this surface in the top view. Now 40 millimeters I have measured. Why? Try to understand. There is a corner here, and from that corner there is an edge. I have explained you earlier. There is edge parallel to width. Check here. From this corner there is edge 28 millimeter long parallel to length. From this corner there is edge 28 millimeter long parallel to length. Similarly, from this corner there is edge 28 millimeter long parallel to length. So this edge we are going to draw. It is 40 millimeters from front. This corner is 40 millimeters from front. Try to understand. Edge through this corner, which is parallel to length, we have already drawn here, hidden line. So the same edge in the top view we are going to draw, but in the top view it is not hidden. Because portion nearer to observer, when observer is watching from top, portion nearer to observer is 28 millimeter wide. But at this corner, the object is 40 millimeters wide. So it is visible. So I have measured 40 millimeters and parallel to length edge I am going to draw here. This is that edge. It is the same hidden edge here. It is visible in the top view now. From front it is hidden, but from top it is not. Now this edge, from this corner to this corner, this edge, it is non-principal edge. Where is this edge in the top view? This edge. So corner of the principal edges, if you join ends of principal edges, then you get this non-principal edge. It will be here. And identical edge will be on the other side also. Check here. From this corner there is an edge 28 millimeters. Similarly, from this corner there is an edge 28 millimeters long. and these two ends of principal edges are connected by this inclined edge. Similarly, on the other side, that is hidden side, there is a similar edge. So parallel to this edge, there is edge on the hidden side. So this is how these two parallel edges will appear here. So this is how we have completed this inclined surface which is visible from top. So here it is horizontal surface and then inclined surface which is visible from top. Now let's proceed. Semicircular slot. It's opening semicircle, or you can say this semi-cylindrical surface. In front view, it shows its semicircular shape. So of course, in the top view, it is a rectangle, and in the side view also it is a rectangle. Let's complete the top view. So draw end projectors. So between these end projectors, we are going to draw that semicircular surface as a rectangle here. But the semicircular surface has parallel to width dimension 40 millimeters. So measure 40 millimeters from front. From front 40 millimeters parallel to width. So from front 40 millimeters parallel to width. And this is how we have completed the rectangle. Now where cylinder or semi-cylinder appear rectangle, you should draw its axis. So from center, draw projector to complete the axis of the semi-cylindrical surface. So this is how we have completed top view. Do you agree? Wait. Watch this surface. Actually, you should check all corners. Corners are formed by three edges. So parallel to length, parallel to width, hidden edges. So watch here, this corner, there is edge parallel to length, or you can say this surface, which is actually not visible from top. This surface will draw, and this surface is hidden in the top view. But this surface shows its true shape in the top view because it has two principal edges, parallel to width and parallel to length. Okay, so measure 8 millimeters. Watch here carefully. 8 millimeters is shown here. This width to be measured vertically in the top view. So from front, measure 8 millimeters here. 8 millimeters. And draw that this edge, dotted edge. And this is that surface. So 4 edges of the surface hidden. And when hidden edges coincide with visible edges, of course, we draw visible edges only. So, but remember, this rectangle is this surface, which is hidden surface. So, this is how we have completed the top view. Now, side view. Actually, in the question paper, side view was not asked. But we are completing because simply we are having practice. So, let's proceed. From side, this surface is nearest to the observer. So let's draw this surface. What is height of this surface? So from top to bottom, this entire curved surface we are talking about. From top to bottom, height is 32 plus 32, 64 millimeters. So from bottom, you should measure 64 millimeters. Or you can draw simply projectors. Where is this surface in the front view? To watch here, this surface has an edge which is parallel to width. Width doesn't appear in the front view, and therefore entire surface appears a line in the front. So this line is the surface, curved surface. Its height is 64. Project here. So I projected that. Okay. Now, what is the length of this surface? 55 plus 25. We are talking about this entire surface. 55 plus 25. 80 millimeters. parallel to width 80 millimeters. 80 millimeters we have already measured here. This surface in the top view is here. So project it here. So here is the rectangle for that surface. But this surface has height 64 only for 25 millimeter width, and 55 millimeter width it has height only 32 millimeters. So draw projector from 25 millimeter I have transferred here, and 32 millimeters I will transfer here, and to complete the shape. This is how we have completed the shape. This is a shape. You can think in this manner also. We can imagine this portion as a different portion. So its shape appears in the front view. So in the top view it is a rectangle, and in the side view also it is rectangle. This rectangle. Only this portion if you think about. So front view shape, remaining two views rectangle. And this lower portion, this lower quarter circular block. This is that quarter circular block. It appears a rectangle in the top view and a rectangle in the side view. And because this upper portion and lower portion they meet tangentially, there should not be any edge here. So this is how we have completed that shape. Now let's continue. Semicircular slot, its end projectors now I have drawn. We already know that semicircular slot, it is semicircle in the front view. So remaining two views it is rectangle. So in the top view it is rectangle, and in the side view. Now parallel to width, in side view horizontal dimension is width. What is a dimension parallel to width for this semicircular slot? 40 millimeters. So you can measure 40 millimeter parallel to width from front. This is front side and this is back side. This is front side. So from front 40 millimeter parallel to width you can measure independently. And I generally prefer measuring independently for smaller details. And otherwise you can take projectors. Since you have already measured 40 millimeter parallel to width here, you project it here. So this is how we got 40 millimeter parallel to width, and complete the dotted rectangle. This semicircular slot is hidden from right side. From top there is nothing to hide that semicircular slot. So watch here, that semicircular slot is visible, but here that semicircular slot is hidden. Okay, now we'll focus on this surface. This vertical edge 8 millimeters at front, correct? Then this edge parallel to width, width is horizontal in the side view, that is 8 millimeter long edge. Then 16 millimeter long vertical edge parallel to height, then 8 millimeters. And then this vertical edge, it is up to the semicircular slot. So this vertical edge up to the semicircular slot. Now here there is an edge from this corner. So first we should draw principal edges, remember. So edges which are parallel to length, width, height axis are principal edges. So this edge is parallel to height. So from top, leave 25 millimeter distance and then draw the edge. And this edge is from semicircular surface. So here is that semicircular surface. So we should draw edge. From top 25 millimeters, here we have already measured. So you can project it from here. Remember this corner corresponds to this dotted edge, because this dotted edge, hidden edge, is that hidden edge from this corner. So this edge is 25 millimeters from top. So we can measure 25 millimeter from top independently or draw projector. So this corner of the surface is here. You cannot draw directly non-principal edge. You cannot draw non-principal edges directly unless you have two ends of that edge. So this principal edge 28 millimeters long here. And once you draw this all principal edges, you will able to draw non-principal edges. That is, simply join these two corners. So this is how we have completed this surface. check whether we have completed the side view. So no, from right side we are watching. So left side corners you will have to check. So from this corner there is edge, and this edge we have already identified parallel to this surface. Correct? Now important thing is, from this corner there is an edge 28 millimeter long. As I have explained you earlier, once again I am telling you, check this surface. We are talking about this surface only. From all these corners there are edges parallel to length 28 millimeters, 28 millimeters, 28 from all these corners. Similarly, from this corner also we should imagine edge 28 millimeters long. And parallel to this non-principal edge there is an edge here. So identical corner is on the other side also. And from this corner there is vertical edge. Up to the semicircular surface there is vertical edge. So similarly, corresponding corner on the other side, from that corner there is vertical edge. But on the other side there is no semicircular surface. So this vertical edge from the corner we should consider up to the bottom. So this corner, from this corner there is edge up to the semicircular surface. But on the other side, from the corresponding corner there is vertical edge up to the bottom. So that edge I am drawing. So this is how side view is also complete. Now we should insert all dimensions as usual. In university paper problem, you were asked to insert only 6 dimensions. Of course, we are not in exam hall. I have inserted nearly all dimensions. Be sure that you are following rules of dimensioning. So this is how we have inserted all dimensions. This is symbol for first angle method of projection. Now you need not write anywhere that this is front view and this is top view. It is understood from the symbol. Thank you for watching the video. We'll meet soon in my next video. We'll solve one more problem on university exam paper, and we'll continue in this manner. Till then, take care. Bye bye.